Hi, this is Rich. I just wanted to talk to you briefly about sizing and effective ways that we can size the work that we are planning to do. The first thing we need to understand is why are we sizing? So sizing helps us to become predictable. In other words, when we are asked how much work can we get done in a certain time period, the person asking that question generally is saying, can I count on you to get done this amount of work? And we say, well, that's going to take us 6 months, or we might say it's going to take us 12 sprints. And we want to be consistent. And in order to do that, we need some sort of universal unit of measurement to help us figure out if the amount of work presented to us can actually be accomplished in that time frame. There's a difference, though, between sizing and estimating. Estimating has a lot of negative connotations that come with it, and we want to sort of divorce ourselves from those negative connotations and simply look at the size of things and say, well, is this more or less work than something else, right? So in order to do that, we have to consider what work has to be done. Do we have dependencies or impediments or risks that might impact the ability to get this work done? We may need to validate some assumptions, but it's not the same thing as estimating. Estimating is problematic because people tend to commit us to whatever we estimate on. For sizing, what we're trying to do is just find out relative to each other, each item we've identified as work to do, is it larger or smaller or about the same as the other bits of work? So when we then talk about planning and projecting a delivery date, we'll use data based on the sizing to help us plan what we can accomplish in the future. And it's important to understand that that's what we're doing. We're not saying, well, today I think this is a week's worth of work, therefore in the future it will still be a week's worth of work. We want to say that today this work is about the same size as the work I did yesterday, and since the work I did yesterday took me a week, then this work should take me about a week, maybe. It can also be used, the notion of sizing can be used to help us identify when work is too big. So when something's so big, we're struggling to say, not only is that larger than the normal stuff we do, but it's so much larger that I think we need to break it down. So the tactic that we use is called T-shirt sizing. Some tips about T-shirt sizing. One, fewer sizes makes easier planning. I like to use just small, medium, and large. And when I look at work, I look to see if any one work item is roughly the same size as another work item. Those things are probably mediums. But if something's smaller than the average, so to speak, then I call that a small. And if it's larger, I call it a large. If it's really, really large, maybe I break that down and I say, is there a way I can subdivide this work to make those pieces, make that into many smaller pieces to give me a little more comfort in? I believe that that's just a little bit bigger, bigger than average, but it's not crazy big. And when things are really, really small, unless there's a whole lot of really, really small, I just ignore them and just say, you know what, we'll count those as small, and maybe we'll get them done a little faster, or they're a little easier to do. Ultimately, though, what we're trying to do is just get not an estimate, I'm sorry. We're trying to understand how much work is there to do. We're not trying to nail it exactly. We're not striving for some super accurate, super precise number that tells us exactly how many hours of labor are involved or anything like that. We're just trying to get a sense of it, right? Remember that the size only makes sense in the context of the team doing the work, right? They're not communicable to other teams. So if one team says something is a medium, another team might think that same work is large or small. And the number of things that a team can get done depends upon that team. So when we take these sizes and use them to plan our work, just because one team says, well, I can do 3 smalls and 2 mediums and a large in one sprint, doesn't mean that the next team over can do the same. They may have a different scale. So a rapid sizing technique. Take the information that you have in your ALM, like Jira, and write down just enough information on some Post-its to identify each one of those work items. Maybe it's the card title. Then, you've had some discussions about these things. You know what they are. We're going to make 3 columns on the whiteboard or on a wall using painter's tape or something. One for small, one for medium, and one for large. And then as a team, we're going to sort those cards out. We're going to say, well, these are all the smalls, these are all the mediums, these are all the larges. And then we're going to inspect the result. And we want to look particularly in the large column. Is there anything in that large column that's really, really large that maybe it's so large it should be in a 4th column that we didn't create? That's a good indication we need to break that work down. And if there's a heavy weight against the small side, maybe we want to say, well, maybe we need a little more distinction, and maybe some of these smalls can be grouped together, or maybe some of these smalls are really mediums. And we want to just gain consensus that these things are small, these other things are medium, and some of these things are large. And we should only take about 10 minutes to do this, so you don't want to draw this out for hours. But it does require that going into it, you've seen the cards, you've had some conversation, some time to digest what is that work. Over time, through practice, you'll get faster and faster at this. Last bit. So we want to put some numbers on things, right? The reason that we want to put numbers on things is because tools like Excel can't make a graph with the words small, medium, and large. It's just not a thing they do. So I like to use the sizes or the numbers 1, 3, and 5 for my sizes, small, medium, and large. And that just makes graphing easy. A note about the ratio there. You can use any numbers you want, but if the ratio is too far off so that smalls are like numerically way smaller than mediums and mediums are numerically close to larges, you get funny looking graphs. So you kind of want to think about it in terms of an even distribution. 1, 3, 5, 1, 5, 10, something like that. Keep it kind of even. One thing I like to do is think of a large as something that if I were to do them serially, I could get maybe 2 of them done in a sprint. And for mediums, maybe I can get 4 or 5 or 6 of those done in a sprint. And for smalls, I should be able to do 1 or 2 smalls a day. So no matter how long my sprint is, I have some relative adjustment there. And the advantage to this is that work that's bigger than the sprint is going to cause problems with measurements and predictability and understanding through math how we're doing. So I never want my large to be bigger than my sprint. If I can get 2 of them in there, that's better. So remember, the numbers, though, they're just about, can I make a chart or a graph? Ultimately, what's important is that I've got some sense of the amount of work there is to do that I can then compare against yesterday's weather, the previous sprints, and say, hey, I did this much last time, 3 smalls, 2 mediums, and a large. So this time I can probably do 3 smalls, 2 mediums, and a large, or maybe 5 smalls, 1 medium, and 1 large, or some combination thereof. Again, the numbers just make that a little easier to divvy up. So you guys know about velocity. I'm sure you've heard that term. Velocity is just the total points or sizes or whatever you want to call it that we did in the last sprint. And we use that to plan the next sprint. So if last sprint we did 10 points, this sprint we want to plan on about 10 points. If we're planning an upcoming sprint and we know that some of the team won't be available, maybe we want to hold back a little bit on those 10 points and say we can only do 8 because Joey is going on vacation on one Friday, or whatever the math is for your team, to say this is reasonable, so that when we go and we communicate this is what we're going to do in the next sprint, we're using data from prior experience to tell us what we should be able to do. Now, how does this all relate to predictability, right? The business is planning. The business needs you to be consistent and predictable in what you do. So if you're telling the business, hey, we can get so much work done in a time frame, and you do that with good predictability, that's good. So how do you use your velocity number to indicate how predictable you are? One way of doing that is to look at a thing called velocity variance. On this chart on the left, I have a yellow line that represents the actual velocity of a sprint team, and a blue line that represents the variance. And you notice that the blue line does not vary quite as widely. That's the standard deviation divided by the average velocity over the past 3 data points, telling us this is approximately what we can expect. So that variance is ultimately reflected as a percentage, and it can tell you sort of the plus or minus error on your velocity. So as it goes up, as you can see in the right-hand side of that graph, as it's going up, it's telling me the team is becoming unpredictable, right? So if you're more than, say, 20 or 25% variant, then your predictability is not very good, and it's hard to be able to forecast when would we be able to deliver some lump of work. The chart on the right represents a lump of work. On the actual spreadsheet, it's about 320 points worth of work, and you notice that the red lines there represent the plus or minus on the variance. The first couple match up exactly because there's not enough data to get a real number, but after we have 3 data points, we can see that our variance is indicating plus or minus this amount of time for the delivery. And that burns down, and as you can see in the lower right-hand corner, it becomes more and more a more and more narrow field as you approach 0, because there's less work, and even if the variance is pretty wide, the total amount of work remaining to do gets closer and closer to 1 sprint's worth of work, and so it sort of becomes less relevant as you burn off the last bits of work. So for a larger project with maybe a higher variance or a lot more points, these things could be giving you indications that the reliability of our delivery date is very broad. It may span a month or 2 months or 3 months. But as we burn down work and we get more refined and our variance gets under control, we get a more refined view of when we're going to deliver. So velocity variance, if you're going to show anybody outside of your team room information about your team, you want to communicate that in terms of predictability, which has to do with your variance, and your variance is a function of your history of velocity. And I'm bringing that up. I know that's kind of outside of the scope of sizing, but how does sizing relate to the rest of the world? This is the connection point. One last bit, and it's about defects. Defects can be kind of tricky, right? We don't know how many we're going to get. We don't know exactly when they're going to show up, and we can't necessarily be sure how easy they are to fix. So an easy way to deal with defects, and one that's pretty effective, is to just assume that all defects are the same size, unless they're completely obviously very small or very large. And when I say completely obviously, like everybody in the room goes, yeah, that's a no-brainer. That's just the wrong color. It's a small. Or, wow, nobody has any idea what's causing that problem. Maybe that's a large. But if it's just we know we got the calculation wrong and we know where the calculation is, it's a medium. By doing this, you eliminate a lot of waste in the system of doing a bunch of unnecessary analysis. Given a defect, we're going to fix the defect. That's already known. We need some kind of sizing information so we can make a plan and say we can get so many of these fixed in a sprint, or if we put this into this sprint, we have to take something else out in order to accommodate the amount of time it will take to fix that. Medium serves that purpose very, very well. Additional analysis is really just a bunch of machination you don't need to do. So that's it for sizing. It's very simple. 3 sizes, small, medium, large. Assign them a point value so that you can make charts and graphs, and use that information for each sprint to say, this is about how much work we can get done in a sprint. Over time, the team may speed up or slow down depending upon a variety of factors. A running average of 3 sprints gives me a good enough number to plan the next sprint. And the velocity variance would be the information I would want to communicate relative to my predictability to the outside world. How predictable am I? How much can you rely upon what I'm saying when I say, well, in the next sprint, we're going to do about 10 or 12 points. Can you count on me? Thank you for your time. If you have any questions, feel free to reach out and ask. Thank you.